So now it's the last video in for this section, and it's example 17, and it says use the Pythagorean theorem and the properties of right triangles to model an equation that fits the problem. One of the cables that anchor the center of the London Eye Ferris wheel to the ground must be replaced. The center of the Ferris wheel is 69.5 meters above the ground, and the second anchor on the ground is 23 meters from the base of the Ferris wheel. Approximately how long is the cable, and what is the angle of elevation from ground up to the center of the Ferris wheel? So here's the picture. This is our Ferris wheel. The perpendicular to the ground is 69.5 meters, right? And this cable that's fixed away 23 meters, I believe, away from this point. And so we need to find theta, and they also want to know the length of the cable, so this side of the triangle. Well, we have two sides. We need to find a third side, and we need to find angle theta. Easy, right? So we know that Pythagorean theorem tells us that the square of the hypotenuse is the square of the sum of the squares of the angle of the sides. Okay, so that will equal to 359.25. Now, x itself, we're going to go with the positive root of that value. And that's going to be approximately 73.25 meters when you put it into a calculator. So you would use the calculator. Okay, so we found x. What is x? X is actually the cable length. So we know the approximate cable, the cable is approximately 73.21 meters. Okay, so the next question, the angle of elevation from the ground, so theta. Well, let's use, this is the approximate value. These are, I'm going to treat as exact values, so I would like to use that. So which trig function of angle theta that uses these two sides, the opposite side and the adjacent side? Well, obviously that's a tangent. So the tangent theta is going to be 69.5 meters over 23 meters. Meters and meters will cancel, so I'm not going to write them. So since we know tangent, how do we find theta? Well, theta is going to be the inverse tangent of that value, 69.5 over 23. And when we put it into our calculator, we're going to get approximately 71.7 degrees if your calculator is in the degree mode. If it's in radians, then you're going to get 1.25 radians. Okay, so, and that's it. So we found theta, we found the length of the cable. We could write that the angle of elevation from the ground to the center of the Ferris wheel, we just call it theta, is approximately 71.7 degrees. All right, so that's it for example 17. And the last question that we're going to look at is example 18, that reads, OSHA safety regulations require that the base of a ladder be placed 1 foot from the wall for every 4 feet of ladder length. Find the angle that a ladder of any length forms with the ground and the height at which the ladder touches the wall. Okay, so what are we looking at? Let's do the picture. So if our ladder is 4 feet, let's say, like for example here, we have to go move the base of the ladder 1 feet away. So right here, per 4. Like if it's taller than 4 by another 4, if we add another 4 feet to the length of the ladder, then we need to move away 1 more foot, like this. Okay, so this is 1 foot, this is 2 feet. Now this ladder is 4 feet right here, and this is 8 feet. So the important thing to note is that these are similar triangles. Why? Because the sides are proportional. Like this side is twice as long as that side, so is this side twice as long as that side. This angle is going to be the same all the time. So, and because these triangles are proportional, these angles are going to be the same. Let's mark them with 2 things, and these angles are going to be the same. Mark them with 1 thing. All right, so this angle to the whole point of the OSHA regulations is to keep that angle with the ground the same. So what do we need to find? Okay, so we need to find first, find the angle that a ladder at any length forms with the ground, right? So this angle theta. So that's the first thing that we need to find. And the second thing is the height at which the ladder touches the wall. So right here, right? The height at which the ladder touches the wall. So this is for the first one. This is for the second one. But I think they want us to keep it general. So for example, if we had another ladder here, so how do we find that height? Well, but let's take one thing at a time. First, let's find the angle theta. I think that angle theta for right now is very easy to find. So because we know we could either use this triangle or that triangle. So for angle theta, it's what we know that this side is 4, this side is 1. So we know tangent, right? Oh, actually, sorry. So we know this side and we know the hypotenuse. We don't know that side. So, and which trig function of theta involve the adjacent and the hypotenuse? And if you said cosine, you're right. So the cosine is adjacent over hypotenuse. So we have 1 foot divided by 4 feet. So that's 1/4. Okay, so how do we find theta? Well, theta is the inverse cosine of 1/4. And when we put it in a calculator, we're going to get approximately 75.5 degrees. Do we have to find the other one, the other angle, the second angle? And the answer is no, because by the design of this problem, our theta is an acute angle. It's the angle in quadrant 1. So we don't need to find angles in quadrant 2 or 3 or 4. They're not like here, the angle for theta is restricted between 0 and pi/2. It's an acute angle. Okay, so we found theta. Now our next problem is to write the expression for how we find the height at which the letter touches the wall. And so what we said before is that these triangles, they're proportional, right? So per each 4 feet of the letter, we're going to have 1 foot away. We're going to move it 1 foot away from the ground. So if this is A, if this side away from the ground is A, then this hypotenuse is going to be 4 times as long, right? So 1 foot, 4 feet, 2 feet, 8 feet. So this is A, this is 4A. So we need to figure out the expression for X. And using Pythagorean theorem, we're going to get X equals the square root of the square of the hypotenuse. So 4A squared minus the square of the side. So that will give us 16a squared minus a squared. So that's going to be 15 square root of 15a squared. And now we can rewrite it as the square root of 15 multiplied by the square root of a squared. And a squared is simplified to just a. So what we have a square root of 15 multiplied by a, and when we put this into a calculator, square root of 15 is approximately equals to 3.87, and we still have a. So the letter touches the ground about 3.87 times a feet from the ground, where a is actually the distance of the letter from the wall. That's it. This was the last video for this section.